this. So HTTP headers. You've seen the basic structure of the request. So here's the kind of headers. Connection tells the server whether it should close the connection or whether you're going to have more requests coming. You can have up to 100 requests in the same TCP stream, so you don't have to renegotiate, do TCP handshake again, so it makes it more efficient. Content encoding shows what sort of content is allowed, so you could, for example, have zipped data going through. Content length specifies the length of the message body if you are sending something like a post request that is going to have data. You have to tell it how long the data is. And content type is the type of data like text, like HTML. And transfer encoding is another message of ways to have data that's chunked in chunks. What's the most secure smartphone? I see someone saying. I think most people think iPhones are more secure than Android in general, although the more expensive Android phones are better. So, and the thing is, iPhones all are pretty good, and they're all the same because they all come from Apple. Android comes from many different developers, and so there are cheap ones that are very insecure and expensive ones that are very secure, and they have different hardware and different properties. So there are hundreds of different Android phones, so they vary. But iPhones do not vary much. They're all very secure. All right, so request headers. This is what you send from your side. You use accept to tell it what kind of content you're willing to accept, like images and such. This is what kind of encoding you accept. You can have authorization, which will send credentials to the server. We'll see this when you do basic authentication. Cookies, submit cookies that you have stored in your browser, that just any kind of data you want to store in a cookie, usually just long random numbers. The host tells you the host name of the server you're trying to reach, the domain.com. If modified since specifies something about how you only want to load a resource, you have a cached version from a certain date, and you only want to load it if it has changed. That's an option to send a request like that. Something like if none match is another way to limit when the server would answer. An origin is used in cross-domain requests where you're requesting from one domain to view on another page. We'll talk more about that in some of the projects. That can be a security risk. Referrer specifies the URL of the page that you click the link on to go here, so that in principle you could use it to track down which of your ads are more effective, but sometimes it exposes private information. And the user agent describes what browser you're using. And the main use of that is to tell whether you're using a cell phone. Because if you're using a cell phone, you probably want to show a different page that is smaller and vertical than the page you would show a browser. So that's the main thing you look at the user agent for, to tell what kind of device is being used to view the page. And in the response, you've got a bunch of tags here, like expire tells the browser how long to cache this before it should get a fresh copy. And you can have other things like controlling caching with Pragma. And set cookie is the main one we talked about here. That's how the server puts a cookie in your browser, so it will be included in future requests to identify you. And we'll talk about some of these other options later. So cookies, resubmitted in every request, your browser remembers them, so every time you go back to that same domain, it will send your cookie. Now, if you have a Yahoo cookie, it will not send it to Google. It will just send it to Yahoo. Each cookie specifies what domains it covers. So you use the set cookie response header, and it will have name equals value, and usually it's just a name followed by random numbers. You could, in principle, put meaningful data in a cookie, like a credit card number or a username or a password, but this is considered a poor practice because it's not necessarily stored in a very secure way on the other end, and it's best to just put a random number in here, which doesn't mean anything to anybody except the server, which has a database that knows that that random name stands for this user, random number. All right, then the browser will add this header to every time you send another request to the same server. It will add the cookie header here. What password manager do you use? Well, actually, this is going to be part of the project coming up in the forensic class anyway. I'm using I think LastPass, but LastPass just got hacked and their security was revealed to be pretty terrible. But I tested a whole bunch of them last semester, and as far as I can tell, they're all pretty terrible. And Vincent Taviso, who's one of the real experts at Google, says, in fact, they are all pretty terrible. So it's still better than reusing passwords, which is the other. I'm continuing to use LastPass. They each have serious flaws, though. Yeah, a lot of people like Bit something. I have a Bitwarden. There's another one. People recommend them. Some people like 1Password. I don't have a simple answer. I haven't bothered to move yet, because even though there are some flaws in LastPass, I'm not convinced that any of the others are really a lot better. It's a whole lot better than my old system, which is having a protected Word document that I could never find, that was on the wrong machine or something. They're a little bit better than that, which is what I used to use. Probably the best thing would be to just have a piece of paper and have a book and write it down on a piece of paper and not lose the book. If you can do that, that would probably be the most secure thing. But I can't hold on to a piece of paper at all. Material objects are useless, so a password manager is best for me. Using the same password everywhere is the worst thing you can do. Try to knock that off. That's a really bad habit. Using Bitwarden, yeah. Some people like Bitwarden. Yeah, I haven't tested that one. Anyway, all right. So here, the set cookie will tell it when the cookie expires. If you don't set the date, then it will, as soon as you're done with this session, the browser will discard the cookie. You can specify what domain it's for. It must be part of the domain that you're using. Yahoo cannot set a Google cookie, but it can set anywhere in the Yahoo domain. This is the fundamental security property of your browser called the same origin policy. So if you're on my web page, you only send cookies for this domain, although my server does not set any cookies. You can't log in. My server is Web 1.0. It's just static content. It's not a shopping site or anything. But if you go to like Kahoot, this probably has cookies and stuff. And the point is, your browser needs to know what domain you're on. It needs to know that this is the domain, so it'll send those cookies. And it turns out that there are a bunch of ways to confuse your browser so it thinks it's at one domain when it's not, and it sends the cookies to the wrong place, for example. This is a fundamental browser security property. It's called the same origin policy, where it will only send stuff to the same origin, and defeating that is a common property of attacks. Yeah?
Is the same origin policy the same thing as first-party isolate?
First-party isolate?
Yeah.
I don't know. First-party cookies are what they call them. First-party isolate, I'm not sure. Might be the same thing.
Okay.
I don't quite know what the isolate part is.
It's for Firefox.
Mm-hmm.
My understanding is that it's the same thing, but I wasn't sure, like, if that, I guess if you call it that policy.
Let's see.
If it goes by different names by different browsers.
First policy isolate, first.
Yeah.
Oh, I don't know. Let me see if I can figure anything out quickly. First isolate. First origin isolate. Or first origin isolate. Okay, let's try that. And maybe, I don't know. First origin isolate in Firefox. Okay, I guess I do not know what that is. First-party isolation is an optional privacy feature built into Firefox. This must be it. That enforces stricter security policies to block tracking. Well, it sounds kind of like what they just put in Safari for Apple to block tracking. So I just see it here. I don't know anything about it, but I do see it, another privacy thing. All right, how is cookie value calculated? That's a very good question, Kessie, and we're going to talk about this. The best thing is for the cookie value to be random and unpredictable. In practice, it's often not. It's composed on a systematic way or an encrypted version of something, and as we're going to see, those are bad policies. If you can guess somebody else's cookie, you can get into their account, and we're going to do things like that in the projects. All right, why Bitcoin trades can't be tracked? Bitcoin trades can be tracked. It's difficult to track because all transactions are public on a public blockchain, but it doesn't store your name. It just puts an account number, and you can keep changing the account number, but people can track it through that. So they can be traced. There's now several companies, the most famous one being Chainalysis, that do track Bitcoin payments, and they're getting very effective. And a whole lot of ransomware payments are now getting intercepted and taken back by the government. So in fact, cryptocurrency being untraceable is much less effective than it used to be. Now there are specific privacy cryptocurrencies, the main one being Zcash, that is designed to really be untraceable, but nobody seems to use it. They all use Bitcoin and Ethereum, even though they're traceable. It's not easy to track Bitcoin, sort of like Tor. It does hide your data to some extent, but a motivated attacker can get in, and there's a lot of money going on it. So there is a special company, like say Chainalysis, and now several competitors that do track financial transactions on the blockchain. So, all right. So other optional attributes, you can specify the path for which the cookie is valid. You can tell it to only transmit this cookie by HTTPS, which doesn't matter as much now as it used to. 10 years ago, a lot of the web was HTTP with no encryption. Now, almost nobody uses HTTP at all. Almost everything is HTTPS, which is a lot better. HTTP only means the cookie can only be sent in HTTP requests. It cannot be sent in JavaScript requests, which is a common way they're stolen, and we'll be doing that in the projects. If you have cross-site scripting, you're able to inject JavaScript in somebody else's browser and steal their cookies. But if they have HTTP only cookies, that technique won't work. And so here's the status codes we talked about. 200 is what you want when it succeeds. 100 is just an informational message. 300 means that you have to go somewhere else. You're referred to somewhere else. 400 means the request had an error. And 500 means there was an error on the server. And there's a bunch of details here. So 200 is the main one, request succeeded. 301 and 302 are things that have moved to a different location. So your browser will be redirected to make another request to a different place. 400 is bad request, like you saw mine. Then there's unauthorized, which means the request was correctly formed, but it requires an authorization code, which you did not provide. So you're denied for that reason. Forbidden and not found. 404, not found, is very common. And then internal server errors. If you write a script on the server, like a PHP script, and it has an error, then you'll get a 500. When you're hacking into a server, trying to send data that confuses the script, when you succeed, you often get a 500 because you managed to confuse the server resource. All right, and so people like to write pages here like unauthorized anyway. All right, so HTTPS is what we're almost all using these days. Almost nobody uses plain naked HTTP anymore, and this is encrypted. Originally, it ran over a protocol called Secure Sockets Layer, which I think was also a Netscape invention. That protocol is out of date and insecure, and nobody uses it anymore. The replacement is now TLS, Transport Layer Security, which uses more modern cryptography. And now everybody pretty much uses TLS 1.1, 1.2, or 1.3. There are various versions. Each one of them is more secure than the last. And so this encrypts your data, and it protects the data in motion, but it does not protect the data at either end. The data on your client side can be seen by applications on the client side, and on the server side, it can be seen by applications on the server side. The only thing HTTPS does is protect it in between, which is pretty good because there are people that spy on wireless networks and at server farms and everything, and HTTPS stops them from seeing your data unless they're able to defeat the HTTPS encryption, which can be done by highly resourced, highly motivated attackers like enemy military and large criminal gangs, but not by average hackers. HTTP proxies cause your data to go through a proxy server. So if you want to protect, if you want to limit the internet use at your company, you don't want people playing games or going to porn sites or something at work, then you set up a proxy so all the browsers cannot connect directly to the internet. Instead, they have to connect to the proxy server and ask the proxy server to load the page. And the proxy server will only load pages that suit company policy. So that's what they are. A service that fetches things on your behalf. And you can have a client-side proxy, which is the one I just described, where people browsing in this room would go to the proxy to get to the web. And you can have a server-side proxy like Cloudflare, which is what I use on my server. So when customers come in to view my page, they do not connect directly to my server. They connect to the proxy, and the proxy shows them a copy of my page, but they never connect directly to my server. So if you want to attack my server, the attack will be blocked by the proxy. At least denial of service attacks will be blocked. But other attacks, like SQL injection, will not be blocked because they involve the data being misunderstood after it reaches the server. Anyway, so HTTPS protects you from man-in-the-middle attacks. It means the data is encrypted, so people intercepting the signals between you and the server will just have unreadable encrypted stuff. Only the endpoints can decrypt it, the client and the server, but not all the things in the middle. So people that try to perform a man-in-the-middle attack where they intercept traffic will not be able to do it unless the man-in-the-middle attack creates a fake certificate and fools one end or the other into believing that they're someone they aren't, typically the client. And we'll do that with Burp. Burp can do that, but it will pop up warnings in a browser telling you that something appears to be wrong. So in an HTTPS proxy, you send a request. It allows the request. Anyway, there's ways to make a proxy on the way of HTTPS. And then there's HTTP authentication I talked about. Basic authentication sends your username and password in base64 encoding, which is not even encryption. It just makes it a little hard to read. It's a very old system and not secure at all. And there's NTLM used for Windows protocols inside Windows networks, digest encoding. These are not commonly used on the internet anymore. They're all weak cryptographically, but if you transmit them over HTTPS, then that adds a layer of strong encryption to them, and then they're okay. But they're not in common use. We'll have a few projects where you play with them a bit, but normally you don't use any of these on the internet. So let's do the last Kahoot for today, which is B. And then I want to show you some projects. Looks like somebody's hungry. Got all the dessert emoticons. There's an attempted injection, that's a good thing. If you could put in those characters and it didn't HTML encode them, then you could insert script on the page. But this is just encoding them as printable characters, but not control characters. We'll talk about that quite a bit. If you output encode your data, then you can use characters like that, but they're not misunderstood by the browser as script tags. Yep, and that's a space encoding. And as you can see, it just prints the raw characters. It does not misunderstand it as a space. So this shows that Kahoot uses correct output encoding, so these special characters do not get misunderstood by my browser as action code. I'll wait for the end of the song. Okay. People still coming in. I see a question asking how does a company do DPI for data transfers, but I don't know what DPI is. Dots per inch for graphics is all I know, but it sounds like you're referring to some other DPI I don't know about. Oh, deep packet inspection. Oh, that could be, yeah. Oh, every modern firewall does deep packet inspection. Layers like Palo Alto firewalls, that means they just look at the full packets coming in. Practically everything is deep packet inspection these days. Firewalls that look only at the headers have gone out of date at least 10 years ago. And now he's asking how they do it for HTTPS data. That's actually a very important question. Let me mention that. If you want to inspect the HTTPS traffic at your company, which you do, then you have to do a man-in-the-middle attack, when you have to change the HTTPS certificates with fake ones, and you have to configure the company browsers to trust the fake one. So there are two ways to do it. The main one is the way I just described, where it would only work for company-issued browsers that have been told to cooperate with the man-in-the-middle attack. The other way to do it is to purchase a fake, authentic root certificate from a certificate authority, which they are not supposed to sell, but they do sell them to large corporations sort of secretly. And law enforcement gets them, and then they can man-in-the-middle traffic, and other nations can do it. So that's what's not supposed to be possible with HTTPS, but it has leaked out that it is done by nation states and large corporations. They can actually intercept HTTPS traffic silently, and you won't know what's happening. It's pretty annoying. Anyway, let's try these Kahoots. All right, so what request header tells the server what page you're coming from? All right, that's the referrer. Good. All right, where can a server specify that a cookie must always be sent with encryption? It's in the set cookie header. When you first set the cookie, you can add the secure flag, and that will tell the browser to only send it with encryption. By the way, you have no way to verify that that happened. However, most browsers do obey the rules. What status code indicates that the page was not found? That's 404. Good. All right, what transport protocol does HTTPS use? Yeah, it's really using TLS. 20 years ago or 15 years ago, it was using SSL. IPsec is used by VPNs and SSH by command line commands in a Linux environment, but TLS is what HTTPS uses in modern browsers. All right, we record these winners, which is V. Well, they'll have to tell me who they are if they want the points. Karen, however, that's your real name. And Tack. And I probably have to tell me who they are. That doesn't look like a real name either. All right. And, okay. It's your real name? Good. Okay, good. All right. All right. So let me stop this recording.